सही बोल रही हो, छीनना चाहिए अपना।
Okay, so good evening, all of you. Uh, I will be waiting for 2 more minutes, right, uh, before we begin, so that everybody could join. Right. So the topic for today's session will be regular languages, right? So this is the beginning of your module number 2, right? So let us wait for 2 more minutes and then we'll begin, right? Meanwhile, one of you can confirm in the chat box if I'm audible and the screen is visible to you. Please, am I audible? You can respond in the chat box. Okay, thank you. Fine. So, how many of you have joined? Almost 20. Okay. Okay, fine. Okay, thank you. Alicia, thank you, Inza. Fine. Okay, so let us begin the discussion today. Basically, what this module number 2 is all about. It is about regular languages. So if I mm, tell you what is a regular language, then it is basically okay. So basically, when we talk about regular languages, see, we have seen about the automata, right? The machines, right? So basically, if we put a regular languages, then what all we have seen till now is we have seen the acceptor of the regular languages, which is finite automata, right? Which we have seen in FA as well as DFA, right? So these are nothing but acceptor, right? There is another thing which we have not seen till now. It is called generator, and this is called regular grammars. Regular grammars, right? So regular grammars, we will see. I mean, after this, we will be talking about regular grammars. What is a grammar? If you remember, basically, in the beginning of this entire syllabus, we have been talking about grammars and languages, right? So grammars are basically what? Grammars are basically generators, right? Generators. So a regular grammar will generate a regular language, right? And basically, to check whether the language is regular or not, we can design a finite automata, right? So in many books, or basically, why to say in many books, actually, how we define regular languages is, if somebody will ask you what is regular language, so the definition itself says that all the languages which could be accepted by a finite automata are regular languages, right? So uh, so basically, finite automatas are nothing. Finite automatas are the acceptor of regular languages, right? Languages. Okay, so spelling languages, regular languages. Okay, and then so there is a generator which generates these regular languages, that is called regular grammar, and there's an acceptor which accept these regular languages, and that is called finite automata. And there is a uh, uh, you can say a representation of these regular languages, which is called a regular expression, right? We can say, okay, a representation or a regular expression. Irregular expressions. Regular expressions are what? Representations. A representation of regular languages, right? So just to start the discussion, I want to make a little understanding what is a regular expression and what we are going to talk in this particular module. Basically, uh, let's say you you design. We have been discussing about problems like string starting with a design of finite automata for string starting with a. We are talking about design of finite automata which contains two consecutive a, or strings ends with ab or aa, right? So we have been designing such finite automatas, right? And if we have to represent such a finite automata, for example, let's say if I say that let's say I have to design there is a language like the language is, let's say, for example, string w, where w belongs to all combinations of a's and b's, or let's say starts with a, right? Let's put it like this: starts with a. W belongs to all string starts with a, right? So how do we design? So this is a regular language, right? uh, this what we have written here, it is called a regular language. Now when we say that design a finite automata for this, so how do we design finite automata for this? So let's say I'll design a DFA for this. So in DFA we will be starting with state q naught as the initial state. We say that it should start with a, yes or no, and once it starts with a, we will go to, let's say, state q1 or q2, whatever. So let's call it q1, because after q naught, let's name it q1, and this will be our final state. After this a, I can get any string of a's and b's, right? So simple, right? So I'm saying language is w, where w starts with a. This is what is a regular language, right? Now I am asking you to make a machine for this. So we have made this DFA for this. Okay, no, this is not DFA, this is NFA. So make it DFA. We'll make a dead state here, q2. If it is starting with b, then we have to go to a dead state, right? So now it is a DFA, right? Let me remove this line from here, right? Now this is what is a DFA. Okay, so what is a finite automata? Basically, finite automata is a acceptor or a representator, right? So if we say that we have to accept all the languages which is following this rule, right, which is following this rule, we have to make a machine, we have to design a machine which is accepting these languages, right? So since this is a regular language, so we can definitely design a finite automata for this, and this is what is a finite automata we could design for this language. Now till this point we have already studied and discussed, right? You note it down if you want to note it down. I'll be clearing the screen and going to the next thing, or you can take a print screen like we are taking in the last class. Okay, so three things we have to keep in mind, right? Number one, what is regular language, right, which we have already been seeing since long. Number two, what is finite automata? This is also we have seen till now in unit number one. Third is what is regular grammar. We have a little discussion on this. What is a grammar? We have said that for any language there is a grammar. Like for English language we have English grammar, right? So as far as the language is following the grammar, it is fine, right? For any programming languages also we have grammar, right? For C language, for Python, for Java, we have a particular set of rules how to write something in that language, and that is called a grammar of that language, right? So but formally we have not studied till now what is a grammar. We will be studying about Chomsky hierarchy of grammar there. Though I have drawn once in the class what is the hierarchy of grammar: a regular grammar, then context sensitive, context free grammar, then context sensitive grammar, then recursively enumerable grammar. So for recursively enumerable grammar we make Turing machine, for context free grammar we make push down automata, and for regular grammar we make finite automata, right? So we have drawn this diagram in the class, but formally we have not gone into detailed discussion of what is a regular grammar, right? So I'll be discussing. So what is the grammar? Basically it is a generator of what? A regular language. So regular grammars will be generating regular languages, right? And what is a finite automata? This is nothing but acceptor, right? So finite automatas will be machines which will verify all the rules and regulations of the grammar, and it will verify a particular regular language. So this part we have seen a little, right? Now what we are going to discuss today, and in one or two subsequent lecture, maybe today and one more lecture will be talking about this, is a regular expression. Now what is a regular expression? In Python, in other languages you might have studied a regex module which we import in our Python program, and then we can write regular expressions. It is same, but here we will be studying regular expression in great detail, right? So in these classes you will be getting a real know-how of what is a regular expression, right? In Python and other languages you will just learn about it in a little informal way, but here we will be studying about regular expressions in a great detail. So just to give you a little idea, so for the language like W, where W starts with A, this is the finite automata. And how do we define a regular language for this? So I'll make some space out here. So for this language, how do we write regular expression, right? So this is my finite automata, right? How do we write for regular language for this language, right? So to design a regular expression for this, we will be writing it like this. See carefully. I have to start with A. So what is the minimum string which is there, which should be there? The minimum string should be A. Yes or no? And after this A, right? After this A, I can have any sequence of A's and B's, right? So it may look a little strange to you what I have written, but slowly you will learn all these symbols, right? So here you can see three symbols, right? Let us see them one by one slowly. This is the first symbol, right, which is a dot. We call it concatenation. This is the second symbol, which is a plus. We call it like union. And this is the third symbol, which you can see here. We call it clean or lean closer, right? Closer. One more symbol we can get sometimes, and that is plus in the power, right? So four symbols we will be looking at in regular expression. So basically, what is a regular expression? It is like arithmetic expression. What is an arithmetic expression? So anything like if we write 2 plus 3 minus 5, this is an arithmetic expression, right? Here what we have two things, right? First thing is what? These are called operands, right? And second thing is what? Second thing is this. These are called operators. Yes or no? So this plus and minus is called operator, and this 2 and 5 is called operand. Yes or no? So in regular expression, like arithmetic expressions, we have operators and operands. What all operators we have? We have four operators. One is this concatenation, one is this closer, lean closer, one is this union, and one is this plus in the power, uh, which is called plus closer sometime, right? They have some meaning. We will discuss about this. So these are the four operators we are going to use. Now, what are the operands in the regular expression? Operands in the regular expression will be the input symbols. Input symbols along with phi and epsilon, right? Input symbol here is A and B. So these are operators. Sorry, these are operands, right? A's and B's. These are operands. We can also have sometime epsilon and sometime phi, right? If you want to note, you can note it down. So this is the regular expression for this language, regular language, right? What this expression is saying, that I'll read it out formally, try to make a sense out of it. What I'm saying here is uh, A concatenated with this bracket is there, and it is inside this bracket we have written A plus B. Plus means union. So A or B, you can read it or A or B. So either A can come or B can come. And to whole power, I have given this lean closer. What is this lean closer? This lean closer means 0 or more time, right? Right. Okay. So let me give you a formal definition of all these, right? So that we can slowly we can make a little sense out of it. So let me share my notes here. Okay, no, fine. So what is a regular expression? It is nothing but a generator, right? Where is my annotation? Okay, yes. So what is a regular expression? It is nothing but a generator which will generate what? A regular language, right? Okay. Now, what is finite automata or FSM, finite state machine, NFA, DFA, whatever we have designed? They are recognizer or acceptor, right? Which will accept or recognize, right? Okay. So that is what is a regular expression is all about. Okay. Now, what all symbols we will have in regular expression? So just I will share these notes to you, so you don't have to worry about this. Whatever I write on that whiteboard, that you need to take care of, right? Otherwise, these notes I will be sharing, right? Okay, fine. So just see carefully what all symbols we have in regular expressions. So first symbol is this lean closer, right? You can just note it down somewhere if it is not written in the notes, that it simply means 0 or more time. 0 or more time, right? So if we write star on the power of a, what do I simply mean? That a can come 0 or more time, right? Makes sense. So let us read what is written in this notes. So that a star means string consisting of any numbers of a's or strings consisting of 0 or more a's. Yes. So in short, you can just remember that this lean closure, whenever we write star in the power, it means 0 or more time, right? That is the meaning of this lean closure. Okay. Now, what is this a plus? If we write plus at the power of anything, this means one or more time. This means what? One or more time. One or more time, right? So a plus means what? A string consisting of one a or string consisting of one or more a's. Now, just to make it a little more clear, let me give you a little know-how about it. So if I say that a plus is nothing but a concatenation with a star, do you follow this? Do you follow this? What does a star means? A star means 0 or more time. What I'm concatenating with it? A, right? So this will be nothing but a plus. Now, if I say in a star, what is the language? What is the language in a star? Phi can come, nothing can, a can come 0 time also, then nothing is there in the language, right? So phi is there. Now a can come 1 time, a can come 2 time, a can come 3 time, a can come any number of time, right? That is the meaning of a star, right? What is the meaning of a plus, right? What is the meaning of a plus? A plus may, this phi will not come, right? A plus means one or more time, one or more time. So a can come 1 time, 2 time, 3 time, n time. A can come n times, right? That is the meaning. So what I'm saying is a plus is nothing but a concatenation with a star. Now what I'm saying is I simply multiply a or concatenate a in terms of string. I'm saying concatenate a with all of this, right? Then it will become a plus. Do you follow this? Let me know in the chat box quickly. Do you follow this? What I'm saying? Quick, 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 quick. Okay, great. Fine. So that is the meaning of a star. Uh, it is really interesting, believe me. Let's say, for example, if I say that regular, like I'll come to all the symbols in a little while. I just want to give you a little more flavor of this. So let's say if I say there's a language which contains nothing, how to construct a finite automata? Because you already know finite automata, right? So how to construct a finite automata for this, right? So when I say finite automata, basically what I'll be doing is I'll be constructing epsilon NFA, right? So now today we will see the usage of epsilon NFA. So if you remember the entire journey which we have seen in the first module, we started with epsilon NFA, NFA with epsilon move or epsilon NFA. We have seen how to convert epsilon NFA to NFA. We have also seen how to convert this NFA to DFA, and we have also seen at last how to minimize this DFA. How to minimize this DFA. We have seen this entire journey, yes or no? Now, what we are going to do in this module is from regular expressions, we will be constructing epsilon NFA, because the rest of the journey we have already seen, right? From epsilon NFA, I can generate minimum DFA, which is the final outcome, right? Because we have done a lot of discussion in the classroom that we cannot basically construct NFA or epsilon NFA in real world, right? We cannot make a machine which is non-deterministic in nature, right? We can only make deterministic machine, right? So DFA is possible, and what is more desirable as a computer engineer, we always want to minimize, we always want to optimize, right? So minimum DFA is the desired thing, but DFA can also be implemented, right? So basically what we will be doing is every time here we will be looking at some regular expression, And once we have developed the understanding of regular expression, we will see a regular expression to epsilon NFA and epsilon NFA to regular expression conversion, right? So any machine, if it is given to you, by looking at the machine, you can write the regular expression for the machine, right? And the vice versa. If you have been given a regular expression, you can design a machine for that, right? So we'll see this entire conversion. So that will develop, the entirely, you can say, the whole idea in your mind, right? The entire journey. We will add one more step behind this regular expression. So basically, we will start with regular expression. That from that we will construct epsilon NFA. From that, if in the question they are asking to construct the minimum DFA, we can construct the minimum DFA. That is the entire journey. So now what I want to show you is how to construct, because you have already seen how to construct epsilon NFA. So if let's say this is the language consists of phi, right? How to write it in regular expression, first of all. So if there is nothing in the language, we can simply write phi as the regular expression also. So this is a valid regular expression. Phi is a valid regular expression. So today I'll show you that what are the regular expression, valid regular expression. So phi is a valid regular expression. Epsilon is a valid regular expression. After this, any input symbol, like if input symbols are for this class, we will consider that input symbols are A and B, right? So every example I will be taking, and you consider that input symbols are only A and B, right? Sometime if input symbols will change, then I'll say specifically. Otherwise, you assume by default that input symbols are only A and B. So sometime I'll say that A, this is also a valid regular expression. Then I'll say A, this is also a valid regular expression, right? And so on. Or B, right? So these all things will be a valid regular expression. A, B, right? A star, B star, A, B star, all these are valid regular expression. So now, just to give you a little glimpse, I'll be just giving you a little idea connecting these regular expressions, these basic regular expression, and designing the finite automata for them. Okay, so let's say we have a regular expression phi. How to construct a finite automata for this? How to construct a finite automata which will accept nothing? There is a difference between phi and epsilon. Phi means nothing. What will be accepted by the language? Nothing. Epsilon means if epsilon will be considered, I mean, even if we get nothing, we will go to the final state, right? Phi does not say we will go to final state if we will not get anything, right? So phi simply, if we have to accept phi, then our machine will simply look like this. So this is our initial state, this is our final state, and that's it. No transition between initial and final state. That means simply we are saying we cannot go to final state. That's it, right? Does it make sense? This is the finite automata which accepts phi. Now, what is the finite automata which will accept epsilon? I think you can easily think. What will be the finite automata which will accept epsilon? This is the finite automata which is accepting epsilon, right? Now, what is the finite automata which will accept A? So here I am making epsilon NFA, right? So I don't have to define all the moves, right? So this is the finite automata which is accepting regular expression A. Similarly, what is the finite automata which is accepting a regular expression only B? It will be like this, right? Right. So this will be the finite automata which will be accepting the regular expression B. Do you follow this? Do you follow this? Phi, epsilon, A, and B? Let me know in the chat box quickly. Do you follow this? You already know how to construct finite automata, right? Now I am showing you how to construct finite automata for regular expressions, right? You can take a screenshot of this. I'll be closing it out. You can take a screenshot. Okay. Done. Okay, fine. Okay, so now let us come to our notes back and let us talk about, so A plus what all we have as a regular expression. First is A star. A star means A will come 0 or more time. A plus means A will come 1 or more time. So plus is called plus closure, means 1 or more time. Okay, again, this meeting will end in next 10 minutes. I will restart the same meeting. You will join the same meeting because of the limitation of 40 minutes of free Zoom, right? So I'll start the same meeting. If it closed, you just immediately join the same meeting, right? Okay. Now see, these are strange for you. Now, what is this A plus B? Can you see this A plus B? What is this A plus B says? Plus means union, right? So A plus B says what? String consisting of A's and B's with either one of them, either A or B, right? One A or one B. So this is OR. This plus is called or union, right? So either A will come or B will come. Are you getting? So this is a valid regular expression. So these are the operators. I told you, right? Operators are this plus. It is called OR operator or union operator. Then there is a dot, concatenation. It is called AND operator, right? AND operator, right? So this is called A or B. Either one A will come or one B will come, right? Okay. Now this is what? This is A or B closer, means A or B can be repeated any number of times, 0 or more time, right? So A plus B closer says what? Set of strings of A's and B's of any length consisting null string, that is epsilon, is also valid, right? Right? Okay, let me show you this, then you will understand it better. So what I'm saying here, again, we have said A plus B, right? A plus B, right? A plus B. How to construct a finite automata for this? We are saying A or B, right? So I will make a finite automata for A. I will make a finite automata for B. Right? And then what I'll do is I will combine them. Now, if you see, this machine will accept either 1A or 1B. Yes or no? Do you follow how we are going? So from Q0, if we follow this path from Q0 on getting epsilon means nothing, we can reach to Q1. And from Q1 on getting single A, we are going on Q2. And from Q2, we can reach to final state on getting nothing, that is the epsilon, right? So either I can follow this path and reach the final state on getting 1A, or I can follow this path similarly and reach to the final state on getting 1B. Is that clear? Are you understanding this finite automata for A plus B? So regular expression is A plus B. Finite automata is this. Is that clear? जल्दी जल्दी बताओ भाई, क्विक. Okay, fine. So this is A plus B. Now let us see what is A plus B star. A plus B star का मतलब क्या था बेटा? What is the meaning of A plus B star? If you remember, it was saying that A or B can come 0 or more time. So A plus B means what? So this is the regular expression. Let us try to understand this. This is the regular expression. What is the valid language for this? The language for this is what? I mean, for this regular expression, if I define the language, so it is saying either 1A or 1B can come. This is the language for this, right? But if I say A plus B star, right? What does that mean? That simply means that now, since we are saying star means 0 or more time, so epsilon is a valid string here. Even if only epsilon will come or nothing will come, then also we can go from initial to final state. Single A can come, multiple A can come, Or similarly, single B can come, multiple B's can come, right? Or similarly, any combination of A, B, A, B, B, or A, B, or A, B, B, anything like that, or B, or can start with B also, like B, A, B, A, B, A, anything can come, right? A, B star means A or B can be repeated any number of times. So first time, let's say A comes, next time B comes, first time B comes, then A comes. So any combination of A's and B's is A's plus B whole star. Does it, first of all, have you understood this language? How this regular expression is accepting this entire language? Now we will construct the finite automata for this. But first of all, do you understand this language? So A plus B star means what? A plus B star means all possible strings of A's and B's, right? All possible string, including epsilon. Do you follow this? Hmm? Do you follow this? Any doubt, please ask. Do you follow this? Any possible A plus B whole star means what? Any possible combinations of A's and B's, right? That is the meaning of A plus B whole star. Now, I have not received any yes message. Do it quick, at least. Anybody is listening? Nobody is listening. Have you understood this language? A plus B star means any combination of any possible combination of A's and B's. That is the meaning. Okay, fine. At least one response. Fine. So now let us try to make the finite automata for this A plus B star. So I'll clear this entire thing. A plus B star. We have to make the finite automata for A plus B whole star. Okay. So first of all, we'll make the finite automata for A plus B. Okay. So it is going to close. I'm going to do one thing. I'm closing this and I'll restart this, right? Before it closes automatically, let me close, right? Okay. So I'm closing it. You all join the same meeting again, right? Let me